Videos we learned how to get around Mars, how to assemble a program, how to execute a program, and how to look at the internal state of the processor during the execution of a program. And this time we're going to look a little closer at the output of the assembler, especially in relation to labels. So labels like those that appear in the data section and labels that appear in the text section. So remember, labels in the data section, like size, are usually going to show up with a load or a store somewhere. And labels in the text section, like loop, are usually going to show up when you're branching somewhere. So labels serve as a convenient way and a portable way to put addresses in your program by name rather than by an explicit address. So if we assemble Fibonacci and go over to the Execute tab, we can look at some of these labels. And first, let's look at that size label. So we can find one place where size is getting referenced, like in this load address instruction, which gets translated to a Louis and an ORI. So remember, so we can actually look at what the address turned out to be. Remember, Louis is loading the top 4 hex digits of the number, and ORI is going to load the bottom part. So really the address we're looking for is 1001004C. So we can go find that. So here's the correct row here, and we have to add C to that. Okay, so this is going to be exactly that data that we stored in size. So if we go back, we saw that we set size to be a one word of data, storing the value 19, and that's what we've got here. You can either convert that in your head, or we can turn on decimal values and we can see 19s right there. Okay, so what about the text labels? Well, let's go find that loop label. So here's the place place that loop is labeling. So loop should have the address of that line of code. So here it is right here. So we know that wherever loop gets referenced, we should see that address. Okay, but in branch, our immediate here doesn't quite look like our address up here, right? So what's going on? Well, remember, branches actually have relative addressing. So when you branch, the new address of the next instruction is going to be PC, which is here, plus 4, so plus 1 instruction, and then it's going to be plus this immediate here. So can make it easier to look at. It's clearly a signed number in 2's complement. Let's turn on decimal. We just see it's -7. So let's do that again. PC, which is right here, plus 4, and then -7. 1, 2, 3, 4, 5, 6, 7. And there we are at loop. So the assembler saw loop, and it did all the math for us to do the relative addressing back up to that label. So that's a little bit more about what the assembler is doing for us, and reminds us how labels in the text section and the data section work.